goes high during starting. Why does?
Sir, torque is directly proportional to phi Ia. To increase the torque, starting current increases.
Okay, but this is not the reason. Any other explanation? Basically, if we see the separately excited motor, if we see the circuit for a separately excited motor, right? Let us take on the example of this separately excited motor, right? In the separately excited motor, if you see the armature current that will be flowing to the motor when we will connect it to the terminal voltage Vt with the supply, there will be a flow of current, yes or no? And obviously there will be a back EMF that will be induced. If we apply KVL in this loop, the equation says that that Vt will be equals to Eb plus Ia Ra. Yes or no? If Ra is the armature winding resistance, yes or
Yes,
no?
sir.
Are yes or no?
Yes, sir.
Right? So if this is the KVL equation which is being satisfied this circuit, armature circuit, then from here can we determine the current? Yes, it will be Vt minus Eb divided by Ra. This will be the expression for the current, armature current. Rearranging this one.
Yes, sir.
Is this fine? Is this fine?
Yes, sir.
See, here the armature current is because of the difference between Vt and Eb, right? And we restricted by this armature resistance Ra, right? So there are the two things on which this armature current depends. Okay, let us see it more deeply. That this Eb, what will happen to Eb? We know that Eb is proportional to, right? Eb is proportional to or equals to Z phi Np over 60A. Yes or no? Keeping these to be constant for separately excited motor, we can say that your Eb is proportional to N. Yes or no? Now, what will happen when your motor is at rest? Means suppose we want to start the motor, so definitely your motor will be at rest. So at rest, what will be the value of N? N will be 0, right? If N will be 0, what about Eb? Back EMF कितना होगा?
0.
Back EMF will also be 0. Yes or no?
Yes, sir.
If N is 0, back EMF is 0, right? So that means at the time of starting, if we see this, we can write that Ia starting will be equals to Vt minus 0 over Ra. Yes or no?
Yes, sir.
That means starting current will be only restricted by the armature resistance during the starting. There will not be any back EMF that will counter this voltage, right? Ra is very small. Ra is kept small to have the high efficiency. Right? Low losses. So if Ra is less, what will happen to Ia? Ia will be
More.
Ia will be very high. This Ra, you could have observed this during the numericals which you have solved, that the value of Ra remains in the range of 0.0 something, right? 0.05, 0.01, 0.02. So the value of this Ra is so small that makes the starting current very high, right? So at the time of starting, only RA, that is very, very low, is only the resistance provided to this current IA. Because of that, your IA goes very high. Obviously, because IA will be high, the torque will be very high, right? The second case is if this IA will be high, your torque will also be high. But we cannot allow this IA to be excessively high, right? We cannot allow this current to go beyond the twice of the rated current. So we had to restrict this current during the starting. Obviously, once your motor has been increased, once your motor is being started, right? It started gradually increasing the speed. Then at that time, this EB will keep on increasing, right? Once your EB will start increasing, your IA will start decreasing. Yes or no?
Yes, sir.
जैसे जैसे मोटर स्पीड अप होगी, ये बैक ईएमएफ जो जीरो थी क्वांटिटी वो डेवलप होने लगेगी. तो बैक ईएमएफ की वैल्यू जैसे जैसे बढ़ेगी तो क्या होगा, बैक ईएमएफ की वैल्यू बढ़ने से ये डिफरेंस कम होगा, इसकी वजह से आईए भी कम होने लगेगा. यस और नो? भाई जैसे जैसे बैक ईएमएफ बढ़ेगा आईए कम होने लगेगा, क्योंकि ईबी की वैल्यू बढ़ रही है, वीटी तो फिक्स है. यस और नो?
यस सर.
तो मतलब ये क्या है कि शुरुआत में जो है, क्योंकि बैक ईएमएफ जीरो है इसलिए आर्मेचर करंट बहुत ज्यादा है. बाद में जब मोटर स्पीड अप हो जाएगी तब तो उसके अंदर बैक ईएमएफ डेवलप हो जाएगा और ऑटोमेटिकली दिस आईए विल बी विद इन दी रेंज. सो वी नीड स्टार्टर्स टू कीप दिस स्टार्टिंग करंट विद इन दी परमिसिबल लिमिट. नाउ हाउ कैन वी डू दैट? हाउ कैन वी डू दैट? द सिंपल आंसर इज, द कन्वेंशनली व्हाट वी डू इज we add on the resistances, we add on the external resistances to the circuit, right? What we do, we add on external resistance in the armature circuit, in the armature circuit, in the armature circuit. This is the external resistance, right? So because of this external resistance, if RA is the resistance of this armature circuit, your IA being restricted by not only by RA, but it will be RA plus R external. So that's why we will be able to limit the starting current. Gradually, as your motor will develop the speed, and because of which the EMF will be developed, will keep on removing this resistance, and as your motor will achieve a final speed of around 90%, then we'll cut all the resistance, external resistance, and your motor will be connected directly to the terminal voltage. You got the thing? You got the thing? Right. One more thing, that if we allow this IA current, even if this is not so high, but in many of the cases, it is always not desirable to have this high starting current during the high starting current, right? You can consider a case of a conveyor belt, right? If we consider a case of a conveyor belt, suppose it's a case like we are having a conveyor belt, over which we are transferring the some of the item which is being placed over here, right? Your conveyor belt is being moving, to which we have connected the motor, right? Motor may be connected directly or through the gearbox, right? Because motor speed is usually high, whereas the conveyor belts, they move slowly. So one mechanism is being used in between the motor and the shaft, that is the rolling shaft, right? That is the mechanical mechanism, such as gearbox, in between the motor and the load, right? Now see, if we operate this motor directly with the supply, there will be a high starting current. That means there will be a high torque, right? That high torque will be suddenly transferred to this mechanical system like a gearbox, and there will be a chance of damage of the teeth if it's a gearbox, right? Because there will be a sudden jerk. That jerk will also be transferred to this system on which you have placed the box which you want to transfer from here to here. So it may also come come out of that? Yes or no? बात समझ में आ रही है? So in such cases, it is not desirable even to have the high starting torque. What we want is the gradual increase in the starting current. Is this clear, बच्चों?
Yes,
Yes, sir.
है ना? ठीक है. So that's why we need low starting current in many of the cases. And nowadays, with the invention of the controllable devices or the semiconductor devices, the starters called as soft starters, right? They have taken over the conventional starters. In course of your in the course of electrical machines, you could have read or studied about the two kind of starters for DC motors. One called as the 3-point starter and other called as the 4-point starter. These could be the two conventional starters, right, which you could have studied. And in both the cases, the methodology adopted was that we will add on the external resistance to the armature circuit, and we keep on decreasing that resistance as your motor will keep on increasing the speed and developing the back EMF. That was the simple funda. I think everybody in this class now understood why do we need starters. How many of you have understood? Please raise your hands. Okay, fine. Thank you. You can put your hands down. Okay. If you have any query or any doubt, you can ask to me directly. Okay. Let us move ahead over the braking. And we'll talk about the electrical braking. As we know, your braking can be of two kinds. It could be electrical braking or it can be a mechanical braking, right? So we'll be discussing about the electrical braking. We also know that in the braking, what happens? Your motor torque opposes the speed, right? In which your motor is being rotating, your motor start developing the torque against to that, right? In that scenario, your motor goes into the braking region, right? To do so, your motor needs to be converted into a generator, right? Now, as per the statement or as per the book, your electrical braking can be of three types. If we talk about the types of electrical braking, we can classify into three categories. One called as regenerative braking. Right? The second one called as dynamic braking. And the third one called as the plugging. Hopefully, you are getting it. Remember that yes, you have studied these all in your course of electrical machines. But yes, we'll brush it up in this course also. Now, what happens in this regenerative braking? We talk about regenerative braking. Basically, to happen this regenerative braking, a condition needs to be satisfied that your E should be greater than the V, such that your IA get reversed. IA get reversed. If we take a case of a separately excited motor to understand this, what is happening is what basically we are saying is the case is suppose we want to regenerate, then in that case this E, which is be the back EMF generated inside the rotor, should be greater than the V, which should obviously be there. Otherwise, you cannot reverse the direction of this current, right? When will be the current in the reverse direction? When EB will be higher than VT, right? तभी वापस करंट फ्लो करेगा. बोलिए भाई, हम क्या चाहते हैं? हम चाहते हैं EB से करंट अब VT की तरफ चला जाए. वो कब हो सकता है? तो तभी हो सकता है जब EB की वैल्यू ज्यादा हो. Is this clear?
Yes, sir.
Is this clear, बच्चों?
Yes, sir.
है ना? मोटर का केस है तो वी हैड अप्लाइड द वोल्टेज, and this current will be going from here to here. It will be going inside the armature circuit. But what we want is the torque in opposite direction. For that, we want this current to be in opposite direction, right? We want current to be in opposite direction. Okay. To current to be in opposite direction, the condition which needs to be satisfied is this EB should be greater than V. Then only this current can flow from here to here. Now, when this EB can be greater than this VT, you have to keep it in mind that we are discussing about the electrical braking, and in electrical braking means braking will happen when your motor will be at certain speed. It will be running at a certain speed, right? So keep it in mind, this rotor is at running condition, right? This rotor is in running condition and we want to deaccelerate this. We want to brake this, right? We want to apply the brake. Now, if we see, if we are having a stiff voltage, means suppose we don't have any option to alter this voltage. If this is fixed at V rated, then at which speed this EB can be greater than this V rated? But we have just read that EB is proportional to N, right? So to have this EB greater than this VT, what should be there? This N should be greater than N rated. Yes or no?
Yes, sir.
By your EB can be greater than V rated only when your speed of this motor will be greater than N rated. Because at V rated, this EB will be at EB rated. We want this EB to be higher than this V. So this can only happen when the speed of this motor will be higher than the rated speed, right? So you can write this in case of DC shunt motor or separately excited motor. In separately excited motor, regenerative braking is possible for speed greater than the rated speed. But when this is being valid, this statement is valid when we have a stiff source. A stiff source means when we don't have any option to alter this V rated, right? Because if we have an option to alter this one, this regenerative braking can occur at any speed. क्यों? क्योंकि अगर हम इसको कम कर सकते तो जिस भी स्पीड पे ये चल रही थी हम अचानक से इसे कम कर देते. अगर कंट्रोल हमारे पास हो कि भाई ये वी रेटेड का अगर कंट्रोल हो तो वी रेटेड को कम करके भी तो रीजनरेटिव ब्रेकिंग की जा सकती है. यस और नो? यस और नो?
यस सर.
राइट, हम कर सकते हैं अगर हमारे पास इसका कंट्रोल है. अगर ये कंट्रोलेबल है तो वी कैन इवन अचीव दिस रीजनरेटिव ब्रेकिंग in at any of these speed. But if we are having a stiff source, we are having a source, right? So that means we cannot control, we don't have any control over this voltage. So for the regenerative braking, this speed of this motor should be higher than the rated one, so that this condition can be satisfied, right? So there are two ways to satisfy this. Either you run your motor at a speed higher than the rated speed, or you lower down this voltage, right? I think it's very clear. Is this clear, bachcho?
Yes, sir.
Yes, sir.
In case of series motor, in series motor, your regenerative braking is not possible. Braking is not possible. Why? कौन बताएगा इस बात को कि why we cannot have a regenerative braking in case of DC series motors? बताओ जल्दी बच्चों। बोलो। Will tell to this to the class. In case of DC series motors, your field current is equals to the armature current. Yes or no? Yes or no?
Yes, sir.
Also, your speed is inversely proportional to the field flux. Yes or no?
Yes.
Yes, sir.
See, what will happen? What we want is speed reduction. Right? We want this to be reduced. Right? For this to be reduced, what will happen? This IA needs to be reduced. Right? Slowly it will reduce because we'll move it in the opposite direction. We'll try to have it in the opposite direction. Slowly it will decrease. But what will happen? Once your IA will decrease, this IF will also decrease. Right? And as this IF will decrease, this speed will increase. Our objective is to get this reduction in the speed, for which we want IA to be reduced, but when this IA reduces, your speed getting increases. So because of the two contradictory objectives, this is not possible in case of series motor. Is this clear?
Yes, sir.
Is this clear?
Yes, sir.
I think it's clear. Huh?
Yes, sir, it's clear.
Also, you have to keep it in mind that when regenerative action takes place or regenerative braking takes place in actual supply system, what happens to the terminal voltage? When machine regenerates, its terminal voltage will rise or reduce or will remain same? Will? बताओ क्या होगा जब मशीन रीजनरेट कर रही होगी? That means it is now working in the generating mode, right? Because the direction of the current is being reversed, है ना भाई? ये मोटर की अब डायरेक्शन रिवर्स हो गई है, तो इस केस में वोल्टेज, टर्मिनल वोल्टेज ज्यादा होगा कि कम हो जाएगा? बोलो, अरे क्या होगा?
सर कम।
इसमें इक्वेशन क्या बनाई थी पहले हमने? पहले क्या थी इक्वेशन की? Vt was equals to Eb minus IARA, राइट? यही तो था। अभी Vt क्या होगा? Vt will be equals to Eb plus IARA. तो Vt will be high or low? Vt will be high or low?
Sir, high.
Right. So answer will be कि in actual supply system when machine regenerates, its terminal voltage will rise. And this was, I think, also been asked in the quiz. Right? Consequently, your regenerated power will transfer to the load that is being connected to that supply system. Right? This supply system, now see, for a regenerative action, there should be the loads connected to that supply system to which this machine, this motor is being attached, such that the power that is being regenerated can be consumed by the loads. Right? If there are not the sufficient load connected to that supply system, then we cannot have this regenerative action again, because the power that is being regenerated needs to be consumed. Either it needs to be consumed in the loads, or you add on the dummy load, right? So that you can absorb that power. So for this regenerative action, there should be the loads connected to the supply system which can absorb this regenerated power. Is this fine? Is this fine?
Yes, sir.
Yes, sir.
Right? So for, should I write for a regenerative action, or braking, let me write the braking only. For regenerative braking, right, loads connected to the line to absorb the regenerated power. Right. So that was all about the regenerative braking, although you could have studied this. Now what happens to the second kind of braking, that is called as dynamic braking? In case of dynamic braking, it's a very simple braking. What we do, we disconnect the armature circuit from the supply and we connect one resistance across it, right? So what we do in dynamic braking, motor armature is disconnected. Motor armature is disconnected from the supply, right? And after that, what we do, and it is being connected across resistance, external resistance, right? And let it be RB. This is the resistance that is to which we connect the motor. The scenario is that instead of connecting the armature circuit, to the supply, we disconnect it and we connect it across the external resistance RB. Again, keep it in mind that we are discussing about the braking. Braking means your motor is being running certainly at some speed. We want to stop it, right? So once your motor is being running, that means there is a back EMF in it. As this path is closed, there will be a current flow. Obviously, as no voltage is being over here, the current will start flowing in this direction. And as it being passed on to this, a heat will generate and the energy will be lost as a heat. So obviously this method will be an inefficient method, as what we are doing is we are wasting the energy that is being there in the rotor circuit, right? But this is the simple way in which we perform the dynamic braking. Is this clear, bachcho?
Yes, sir.
The last one is the plugging. In plugging, what we do, again, we disconnect, not only we disconnect, but we reverse the polarity of the applied voltage, right? What we do for plugging, the supply voltage of a separately excited motor is reversed right? So that back EMF can assist the forcing armature current, right? So what basically is the scenario? Scenario is that we not only have disconnected this from the supply, but we have reversed the polarity. In fact, what we did is, for this case, if we are taking an example of a separately excited motor, so what we are doing, we are keeping this field current as it is, but for this case, instead of applying the voltage with the positive polarity over here, we have reversed the polarity, right? So that your IA now will be flowing like this way, right? Also, what we do to have the means discharge or absorb of the power with a higher rate, we add on a one external resistance also, like we did with the dynamic braking. So in case of plugging, we reverse the polarity of the applied voltage so that current can be reversed, direction can be reversed for the armature current. Also, we add on an external resistance so that the energy that is being generated can be consumed fast, right? In all the cases, you could have seen that we had tries to reverse the polarity of the current, because what we know that for the separately excited motor, in case of separately excited motor, excited DC motor, what happens to the torque is proportional to phi Ia, but in case of separately excited motor, this phi remains constant, right? This remains constant, so we can say that your torque is proportional to Ia, and this torque is also dependent upon the direction of this current, sign of this current, right? So to have the torque in the reverse direction, we wish to have this current in the reverse direction. I think it's clear. Is it clear, bacho?
Yes, sir.
Yes, sir.
If it is clear, unit 2 is complete, right? You can do one or more numericals on this braking and the starting if you wish to, but unit 2 is complete. Now we'll move towards the unit number 3. Unit 3 is basically dedicated to the induction motor drives. Right? Now this induction motor drives, we know that induction motor is a AC motor, right? Induction motor is a AC motor. So definitely what we will be studying now, we have studied the DC motor drive, now we will be studying the AC motor drive. Obviously, if you see the conventional method, then if we are having a induction motor, which is a AC motor, right? And it comes in two variants. One, the single phase, and other the three phase, right? If we talk about particularly the three phase induction motor, and we are having a three phase supply, then obviously we can directly connect our motor to this supply if the supply rating is matches to the motor, then we can directly connect it and your motor will operate. Obviously whatever load you have connected to this, it will also govern that. But what will be the difficulty or what will be the limitation? Limitation will be that in such scenario the speed of this motor will be fixed or constant. Yes or no?
Yes, sir.
Yes or no?
Yes, sir.
Right? So in such a scenario, which obviously have been used in the past, to have the speed control, one mechanical systems were used like the gearboxes to have the different speed or multiple speed. right? Your motor runs at the fixed speed, but if your requirement of the load is such that it requires the multiple speeds, then what you can do is you could have used the gearbox, or certainly the other mechanical transmission systems which can provide you the variable speed. So this strategy were used in the very beginning when either the control circuitry of this induction motor, control circuitry for motor is very expensive or inefficient. But with the invention of the controllable switches, nowadays your induction motors are very much widely used for variable speed drives as well. Okay, in the past, your induction motors were only used for fixed speed applications, right? But nowadays, from last 2 decades, your motor, 3-phase induction motor, it is being used in variable speed drives. As now, because of the invention of these controllable switches, the control becomes very easy and inexpensive. Is this clear? We will study more in the next class. That's it for today.